Managing resources efficiently is critical for any high performance Java application. These resources may be anything from a database connection to a TCP IP socket connection or a collection of files. Wherever we want to prevent the overhead of creating and destroying these resources again and again and reuse the existing ones. A pool is a collection of reusable objects. Instead of creating and destroying these objects repeatedly, a pool manages them efficiently, saving time and system resources. In this video, we will explore Apache Commons Pool, a robust library to manage resource pool effortlessly. It provides features like object validation, idle object maintenance, and configuration for pooling behavior. By the end, you'll learn how to use its core component with a simple example. Let's get started. Before we dive into the implementation, let's look at why Apache Commons Pool is essential for managing resources efficiently. It has many features that we will be covering. Reuse existing resources instead of creating and destroying them repeatedly, saving time and memory. You control how many resources are in the pool, how they are validated, and their life cycle. It ensures your resources are safely shared among multiple threads, reduces boilerplate code, and makes your application more maintainable. Let's understand the core components required to implement Apache Commons Pool in your project. This is the actual resource we want to manage in a pool. It can be a database connection or socket connection, which are most commonly used. This creates and destroys resources for the pool. It defines how the resources or connections will be initialized or disposed of. Defines the pool's behavior, like size limits and validation rules. This makes the pool highly configurable by enabling you to define the minimum and maximum idle connections, max allowed capacity, etc. We will look at various options in great detail later. The actual pool that manages resource creation, validation, and reuse. Now let's head over to pool implementation from scratch. Open Eclipse IDE or any other of your choice. Create a new project. We will create a Maven project. Provide group ID, artifact ID, and a project name. Click Finish. The project is created. Open its pom.xml. We need to add a dependency for Apache Commons Pool. Go to Maven repository and search for Apache Commons Pool. Click the latest version. Copy its dependency for Maven back to pom.xml. Add a dependencies section and paste Apache Commons Pool dependency that we just copied. Right-click the project and update project to download its jar and add it to class path. As a first step, we will create a connection class. This will represent a connection object or the object that needs to be managed by the pool. Define its package and provide class name. Add a connection ID field to identify each connection individually. Initialize this field in the constructor by generating a random ID using UUID class. Also generate a getter method for this ID. Define a method createConnection. This should contain the connection creation logic as per your requirement. For now, simply print a message. Similarly, define another method closeConnection. This method should contain the logic to close the connection as per your requirement. Print a message here as well. Next, define a connection factory class. This class will have various lifecycle methods that the Apache Commons Pool will call when the connections are created and destroyed. This class should extend base pooled object factory from Apache Commons Pool. It is of generic type and its type represents the type of object managed by the pool. So, in this case, its type will be connection class, since its object we have to manage with the pool. If you look at this class, it has methods to create, destroy, passivate objects. We need to override required methods as per our requirement. It is asking to add some unimplemented methods. Add these. In the create method, create a new connection object and call its create connection method. Return this object. Object factory wraps the actual connection object inside a pooled object to manage other information such as its state, timestamps, etc. For wrapping the object, it calls a wrap method while creating. Simply return an object of default pooled object, providing it the connection object. Default pooled object implements pooled object. We also need to implement destroy object method to define how to shut down our connection object, such as calling close on a database connection, etc. Default method of object factory does nothing, and so we have to override it. Copy its definition. Change this generic type to connection class, the type of objects that we are managing in the pool. To get the connection object from pooled object, call its getObject method. Assign it to connection variable and call its closeConnection method. Our object factory is ready. Next, create a connection pool class that represents a pool of objects. This class needs to extend generic object pool class from Apache Commons Pool. It is also a generic class whose type should be the objects that need to be kept in the pool. In this example, it should be connection. It is asking to implement its constructor since there are three overloaded constructors. We will be using the one that takes both the connection factory and configuration objects. The connection pool is also ready. Now create a main class for testing our connection pool. Define a main method. First, we will define connection pool configuration, which is an object of generic object pool config. This is also a generic class whose type represents the type of objects in the pool, which is connection in this case. Let's understand some basic configurations related to the count of objects supported by pool. There are three configurations with respect to the count of objects maintained in the pool. Minimum idle, which means the minimum number of idle objects sitting in the pool all the time. When required, the pool will reuse objects out of these idle objects only. Maximum idle, the max number of idle objects that can remain in the pool. Any objects more than the idle count which are not being used for any task, such as executing an SQL query for database connections or reading writing a data packet for socket connections, are destroyed. Max total, maximum number of objects that can be handled by this pool. So, if max total is set to 10, then the pool will at most create 10 connections. And if there is a requirement for 11th object, the pool will throw an error. Let's look at these configurations in action now. Set minimum idle connections that need to be maintained in the pool with its setMin idle method. Set maximum connections or max count of objects that can be maintained in the pool at any time with its setMaxTotal method. Create an object of connection pool. Here we need to pass a connection factory. We will supply an object of our connection factory class and the configuration object that we created above. Now to add a connection object to the pool, we need to call its addObject method. This method throws an exception. For now, we will just declare at the method signature. AddObject will create a new connection object. It will internally call the create method of our connection factory, which defines our mechanism for creating a connection. AddObject method should only be called when you want to create a new connection. Generally, it is called initially to populate the pool with required number of connections initially. Later, we only reuse those connections by fetching them from the pool. To fetch a connection from the pool, use its borrowObject method. This will return a connection object. Assign this to a variable. After getting the connection, we can use it as per our needs. And then we should return it back to the pool using its returnObject method. Remember that returnObject takes a connection to return as argument, and it should be an object that we got from borrowObject method. You can't create a new connection directly and call returnObject. This will give you an error. Let's borrow another object and return it again. Run the program. You see, we get only one message of creating connection while we borrow two objects from the pool. This means that the pool is reusing the same connection if it is available. Now let's borrow another connection from the pool and return it back. Run the program again. Now we get two messages for connection creating. This is because borrow object first looks for an idle connection in the pool. If it finds, then that object is returned. If it does not, and the max total setting allows, it creates a new connection. Since we borrowed a connection at line 13 but did not return it, another borrow object at line 14 will try to create a new connection. If we had called return object in between, then the same connection would have been reused. To further show this, let's define a list of connection objects. Loop from 0 to 4, that is for 5 times, which is equal to the max connection count that we have defined. Every time borrow an object from the pool and add it to the list. Remove all this code. We are not returning any connection back to the pool. What should happen when I run this? It should create 5 different connections. Let's run it. It is creating 5 connections, and this is because we have configured the max connections to 5. Now let's increase the loop count to 6. Run it. It creates 5 connections and the program hangs. This is because connection pool has created max connections, which is 5, but it requires one more connection and it keeps on waiting for creating that one connection. There is a setting to block for new connection when the pool is completely full and a new connection is required beyond the max count. This setting is controlled by a method which is setBlock when exhausted. Its value is true by default, which means that the pool will block forever when it is full and it has to create a new connection. Set it to false. Now it should give an exception. Look, there is an error, pool exhausted. The connection pool is very configurable. You need to configure it as per your requirements. In the meanwhile, if we return a connection to the pool, then it will not fail and keep on reusing the connection. Now let's say we return a connection in the second last loop iteration. Run this. It works since it gets a connection to borrow. Just like there is a minimum idle connection setting, there is also a max idle connections, which means the maximum number of unused objects in the pool. When we return an object to the pool, it goes into an idle state and the pool maintains a queue of idle objects. Max idle represents the maximum number of idle connections. So, when we return a connection to the pool and after returning, if the total number of idle connections becomes greater than the max idle count, then the pool closes this connection so that resources are not wasted by being idle. Let us change min idle to 1 and set a max idle count to 3. Now, after this loop, we have 5 connections borrowed from the pool. So, if I return 4 connections, then the number of idle connections become 4. And this means that there is one connection exceeding the max idle connections that can remain in the pool. So, the pool will close one connection. Let's run this. See, it is closing one connection. Now let's change the max idle count to 2. Now there are 2 connections more than the max idle allowed. So, the number of connections that should be closed will be 2. Run it. 2 connections are closed. Before creating a new connection or borrowing an existing connection from the pool, you might want to check if the connection is still valid and will work upon borrow. Apache Commons Pool allows you to do that. Its configuration has a test on borrow flag, which you can set to true with its set test on borrow method. Also, you need to implement a validate method in connection factory. Open its superclass base pooled object factory and look for its validate object method. By default, it returns true. You need to override it in your factory implementation according to your validation logic. Change the generic type to connection object. Print a message here. Run the program. Look, every time it is borrowing a connection, it is validating it. If the validate method returns false, then the connection will not be added to the pool. As a best practice, we need to periodically test the connections that are placed in the pool to ensure that they are healthy and ready to carry out the task when required. So, if the pool is of database connections, then we can execute a simple SQL query, or if the pool is of socket connections, then periodically read or write data on a socket. It would be quite a task if you need to write it on your own, since these kind of operations are performed on a separate thread which keeps on running in the background. Apache Commons Pool allows you to implement health checks easily with some simple configurations, and it manages the background operations on its own. To start performing health check, you need to set its test while idle flag to true. This flag configures the pool to perform repeated operations on all idle objects in the pool. The frequency of such health check is also configurable through its set time between eviction runs method, where we can specify the interval. Let's set it to 5 seconds. Finally, what you need to do as a health check task is written inside validate object method of connection factory. So you can execute an SQL query here or a socket read write according to the type of pool objects. If the validate object returns true during health check, the object is considered healthy and okay. Otherwise, it is removed and the pool will automatically create a new object to maintain the idle number of objects according to domain idle configuration. To keep the program running, let's add an infinite loop here. There are two idle connections after this, so health check will be performed on two connections. Let's check. Run the program. Let's clear this. Look, it is running health checks on two connections. If you see the IDs, both are different and in each run, the IDs are same, which means that every time same connections are being tested. You can also control the number of objects that should be tested in each health check with its num test per eviction run method. Set it to 1. Run again. Clear this. Look, it is now validating only one object. Let's wait for 5 seconds. The second object is tested. Look at the IDs. They are different. So, to conclude, Apache Commons Pool is a very efficient and lightweight library that can be used to manage a pool of objects. It is highly configurable and easy to implement. You can explore its configurations and play around with them. Hope you liked the video. See you in the next one.